All right, so we have the last section in section 2 point or chapter 2, which is 2.4, which is essentially how fast. How fast are we going? And when we're talking about fast, we're talking about velocity. Now, we've already talked about velocity as it pertains to a position time graph. So as we talk about velocity, we've talked about that is the slope of a position time graph. But when we talk about velocity, we got a couple other terms we need to bang out. The average velocity. And the average velocity is the ratio of position to time during an interval which a change has occurred. So really you're looking at your general slope. So if I go to this graph on the next slide, you can figure out your average slope, your average velocity between here and here, here and here, here and here, here and here. That's kind of the way you can figure out your average velocity as you go. So the equation for velocity is equal to distance divided by time. So what would the units for velocity be? Distance is in meters, time is in seconds. So it would be meters per second. And a lot of times in ninth grade, I know you just learned this as velocity is equal to distance divided by time, and that's fair enough. That's fair enough, but you want to make sure you have the change there. So we've already talked about in 2.3 that the slope of a PT graph is velocity. Now, let's also talk about what is the difference between velocity and speed real quick, as we've already done that. What is the difference? Speed is just a number, so it's a scalar quantity. Speed is just a number, it's a scalar quantity. Velocity is speed with direction. So when we're talking about velocity, it's the same direction as displacement. And then we can have average velocity and average speed, which are the same thing, except velocity doesn't really have the speed involved. So if you wanted to figure out the absolute, or the average speed, you're going to take the absolute value of a PT graph, of the slope in a PT graph, which we just kind of circled on the next slide already. So we have average velocity, average speed, and then just like we had instantaneous position, which was position at one point, we can have instantaneous velocity, which is your speed and direction, because we're talking about velocity, it's your speed and direction at one particular instance. So that would be instantaneous velocity. All right, kind of one thing we got to wrap up here. We've talked about PT graphs already, so if we take a look at PT graphs, here's a very nice example of a PT graph. Well, in a PT graph, we all have, for the most part, we have constant velocity throughout the whole graph, as we kind of do here, and we're able to graph it. We have a very linear equation. Well, remember, linear equation is y is equal to mx plus b. But we can convert y is equal to mx plus b into something very important for us in regards to our position time graph, where we can take it and transform it into d is equal to vt plus di. See how d is a nice substitute for y, v for m, x for t, and b for di. Now what does each of those values mean? D equals position, v equals average velocity, t equals time, and di equals initial position. And this is an equation that we're going to use when we start working a little more in depth with position time graphs. So you probably remind me in class tomorrow to hand out a note card, because what you're going to want to do is write down equations as you go, so you have them for your test. So here's kind of your first equation to write down of the year, and there's your second one. So kind of keep that in mind as we go. I'll give you a note card tomorrow, but we can talk about that more in class. So there is chapter 2.